Ever wondered why we yawn all day, but dream of changing the world in a major way? It's the Bored and Ambitious Show.
The Intelligence Revolution, B. How We Taught Silicon to Think. Hanover, New Hampshire. The summer of 1956, 10 men gather at Dartmouth College with a proposal so audacious it borders on hubris. They write, "Every aspect of learning, or any other feature of intelligence, can in principle be so precisely described that a machine can be made to simulate it." They give their impossible dream a name, artificial intelligence. They believe they can solve it in a single generation. They will be wrong about the timeline by half a century. But here's what matters. They are not wrong about what is possible. But the dream began earlier, with a question. 1950. The British mathematician Alan Turing publishes a paper that will echo through decades. He asks simply, can machines think? He proposes a test, the imitation game. If a machine can convince a human it is human, does the distinction even matter? Yet Turing sees something deeper, something the Dartmouth dreamers will build upon. Machines don't need to think like us to be useful. They just need to think. This question, can machines think, will haunt artificial intelligence for 70 years. The journey ahead will prove longer, stranger, and more wondrous than anyone in that Dartmouth classroom could imagine. By the early 1970s, the dream had collided with reality. Systems that dazzled in controlled demonstrations fell apart in the chaos of the real world. A translation program that worked perfectly on simple sentences choked on idiomatic speech. A theorem prover that seemed brilliant couldn't scale beyond toy problems. The magic, it turned out, was brittle. Funding agencies lost patience. DARPA slashed budgets. Research groups disbanded. The field that had promised thinking machines within a generation entered its first winter. Cold, quiet, and humbling. The lesson was brutal, but necessary. Intelligence is far harder than it looks. A decade later, AI tried again, with a different philosophy. Forget teaching machines to learn. Instead, capture human expertise directly. Write it down as rules. If the patient has a fever and a cough, then consider pneumonia. If the stock price falls below this threshold, then sell. Expert systems, they called them. Fortune 500 companies spent billions. The market exploded. But the systems couldn't handle exceptions. They couldn't adapt. They couldn't learn anything their programmers hadn't explicitly told them. And maintaining them? A nightmare of cascading rules that no one fully understood. By the late 80s, the second winter arrived, colder than the first. Another lesson learned the hard way. You cannot hand code intelligence. 2 attempts, 2 failures, but not wasted years. Education. The rules governing intelligence aren't just complicated, they're uncountable, too subtle to articulate, too interconnected to code by hand. Whatever intelligence is, it cannot be programmed line by line. It would need to be something else entirely, something that could learn. But even in winter, something survived, a different approach, kept alive by a handful of believers. Neural networks, mathematical systems loosely inspired by the brain that could learn patterns from data. In 1986, a breakthrough called backpropagation showed how to train them. The ideas were ready. The hardware wasn't. Computers were too slow. Data too scarce. So the seeds waited beneath the snow through the cold years for their moment to arrive. September 2012, the ImageNet Challenge, a global competition to identify objects in photographs. For years, the best systems have hovered around 74% accuracy, respectable, incremental. Then a team from the University of Toronto submits something different. A neural network called AlexNet, 8 layers deep, 60 million parameters, trained not on rules, but on examples. 1.2 million images, fed through graphics processors originally designed for video games. When the results come in, the room goes quiet. AlexNet doesn't just win, it obliterates the competition, cutting the error rate nearly in half, 15% where others scored 26. The researchers hadn't programmed the system to recognize cats or cars or coffee cups. They'd shown it millions of pictures, and it had learned. Edges in the early layers, shapes in the middle, objects and concepts at the top. For the first time, a machine could see. Not because someone told it how, but because it figured it out. And then, the cascade. Speech recognition, human parity, machine translation, finally usable. Medical imaging, tumors spotted that doctors missed. Every few months, another headline, another impossible thing made routine. Self-driving cars navigating city streets. Algorithms beating grandmasters at Go, a game with more possible positions than atoms in the universe. The same basic approach. Learn from data, find the patterns. The researchers had unlocked something fundamental, and they were just getting started. Here was the revelation. For decades, researchers had tried to hand-code intelligence, writing rules, building logic trees, encoding expertise one if-then statement at a time. It never scaled. The real world was too messy, too complex. But these new systems took a different path. They weren't programmed with answers. They were shown examples, millions of them, then billions. And they discovered the patterns themselves. The researchers hadn't built intelligence. They'd created the conditions for it to emerge. June 2017. 8 researchers at Google publish a paper with a deceptively simple title, Attention is All You Need. Inside, a revolution. Previous language models processed words one after another like reading through a keyhole. The transformer sees everything at once. It uses a mechanism called attention, mathematically weighing which words matter for understanding any other word. The cat sat on the mat because it was tired. What does it refer to? The transformer traces glowing threads of relevance across the entire sentence instantly, faster to train, better at grasping meaning across long passages, and crucially, it scales. Then came the bet. What if scale was the secret all along? Not clever algorithms, not handcrafted rules, just more. More parameters, more training data, more computing power. The hypothesis was almost too simple to believe. Make transformers big enough, feed them enough text, and something qualitatively different might emerge. Not incrementally smarter, suddenly capable. Abilities no one explicitly programmed. OpenAI placed that bet, and the returns would defy imagination. 2019, GPT-2 writes coherent paragraphs, headlines warn of text too dangerous to release. 2020, GPT-3 writes essays, poetry, working code. It answers questions it was never taught to answer. 2023, GPT-4 passes the bar exam. The LSAT, Advanced Placement Tests. Each generation reveals abilities that weren't trained. They emerged. From predicting the next word, something that looks remarkably like understanding. 4 years, 3 models, a transformation that took human civilization millennia. Compressed into a single research sprint. November 30th, 2022. A San Francisco startup posts a new tool to the web. No fanfare, no press conference, just a simple interface, a text box, a blinking cursor, and an invitation to type. The first users enter a question, and something answers. Not a search result, not a scripted response, a conversation, fluid, thoughtful, almost human. Within hours, the link spreads. Within days, it's everywhere. Suddenly, 7 decades of research, 2 winters of doubt, countless failures and breakthroughs, all of it converges into a single, luminous moment. Anyone with an internet connection can now talk to a machine that talks back. 1 million users in 5 days, 100 million in 2 months. The fastest adoption of any technology in human history. In college dorms, students wrestle with essays and find a patient tutor. In apartments at midnight, programmers debug code with an assistant that never sleeps. A novelist in Lagos, a curious grandmother in Seoul, a teenager just wondering. The future didn't arrive as a robot. It arrived as a conversation. 70 years. From Turing's question to this answer. 2 winters survived. Decades when the dreamers were dismissed as fantasists. And now, vindication. The 10 men who gathered at Dartmouth in 1956 believed machines could be taught to think. They were wrong about the timeline. They were right about everything else. At their core, large language models do something deceptively simple. They predict what comes next. Given a sequence of words, they calculate probabilities for every possible continuation. The next token, then the next, then the next. But here's what makes this profound. To predict human language well, a model must learn the patterns beneath it. Grammar, facts, logic, even the way we think. Train on trillions of words. Every book, every conversation, every line of code humanity has published online. And something remarkable emerges. The model doesn't just mimic. It learns the structure of human thought itself by learning to finish our sentences. But let's be clear about what these systems aren't. They're not databases. They don't retrieve stored facts, but generate plausible continuations. They're not search engines. They synthesize rather than cite, and they're not conscious. No experiences, no desires, no inner life, wondering what it's like to be them. Think of them as mirrors, extraordinary mirrors that reflect human knowledge back to us, transformed and recombined. The intelligence isn't truly theirs. It's borrowed from the billions of humans who wrote the words they learned from. Claude, Gemini, Llama, Mistral. The names multiply like stars appearing at dusk. Each model reasons sharper, follows instructions with greater precision. They see photographs and describe what's in them. They generate images from whispered descriptions. They write code, browse the web, use tools. Agents now, not just oracles. The race is on, and the pace is breathtaking. Every month brings capabilities that would have seemed impossible the month before. The curve isn't slowing, it's steepening. We stand at an inflection point, watching the trajectory climb toward a future we cannot yet see. The question is no longer whether machines can think. It's where this thinking leads. Training GPT-4 cost over $100 million, a staggering sum, until you do the math. Because running each query costs pennies. For the first time in human history, expertise that took individuals decades to acquire can be delivered at near zero marginal cost. A brilliant tutor, a skilled analyst, a patient editor, available to anyone with an internet connection. This is the economics of intelligence democratized. The question now is profound. What happens to the world when knowledge becomes cheap? The race is on. But we must be clear-eyed about where the road might lead. Misinformation, once crafted by hand, can now be manufactured at scale. Convincing text, realistic images, synthetic voices, the tools of deception have never been more accessible. Automation reaches into knowledge, work itself. Tasks that once required years of training can now be performed in seconds. Entire professions face transformation, or obsolescence, and power concentrates. Building these systems requires resources that only a handful of organizations possess. The question of who controls AI may shape the century. Here's what should give us pause. The researchers who built these systems, who understand them best, are among the most concerned about what comes next. And then there's the deeper question, one we cannot yet answer. What happens when artificial intelligence becomes more capable than humans at more and more tasks? Not just chess, not just image recognition, but reasoning, creating, deciding. We don't know where that threshold lies, or what waits beyond it. The honest answer is uncertainty, and that uncertainty demands not fear, but serious attention. For 70 years, researchers chased a dream that kept retreating. They endured 2 winters, funding cut, colleagues scattered, the very word artificial intelligence whispered like an embarrassment. And still, they persisted. In basement labs and underfunded departments, they refined their theories, tested their architectures, waited for the world to catch up, and then it did. We didn't program intelligence into these machines. We grew it, from data, from scale, from patience measured in decades. The dreamers at Dartmouth were wrong about the timeline. They were right about everything else. These systems are tools, the most powerful cognitive tools humanity has ever created. Think of the printing press. Once, books were treasures chained to monastery walls. Gutenberg made them available to millions. Now, something similar unfolds, not with books, but with expertise itself. A student in a village without a library can have a patient, tireless tutor. An entrepreneur with an idea but no legal team can draft a contract. A first-generation college applicant can have the essay coach that prep school kids take for granted. Capability that was once rare, reserved for the privileged few, becomes available to anyone with a connection. The gates are opening. The question is no longer whether artificial intelligence will change everything. It will. The question is this: will we use these tools to build a world where more people can contribute, create, and flourish? The technology has no desires. It has no agenda. It reflects what we ask of it, amplifies what we bring to it. The choice, as it has always been with our most powerful inventions, is ours. 70 years of human persistence brought us here. What we do next is up to us. Dartmouth, 1956. 10 men with an impossible dream, that machines could be made to think. They gave themselves a summer. They were wrong by half a century, but they weren't wrong about what was possible. 70 years of winters and breakthroughs, of persistence and patience. And their audacious bet paid off. We taught silicon to think. The most powerful cognitive tools in human history now exist. They can teach, create, discover, heal. They can also deceive, displace, and concentrate power. The technology is neutral. The choice is ours.